Ma'am has been working as HOD in the Department of Homeopathy Pharmacy in Bharati Vidyapit, Homeopathy Medical College, Pune, Maharashtra. Ma'am has been working since 1993 as the head of the department to present, and ma'am is guiding various number of UG, PG, and PhD scholars, students till now. Ma'am has attended various conferences, and ma'am has also did various research publications from various research publications in Scopus, UGC, Web of Science, and peer-reviewed journals also. So ma'am has been also worked as the paper setter in many exams, and ma'am has also been attended the workshop conducted by National Commission of Homeopathy regarding PG syllabus preparation at Janakpuri, New Delhi. Ma'am has also did industrial training at Wilmer Shobe Private Limited, Noida. Ma'am is also a chairman for university examination of UG, PG, and PhD from 1996 to present. So we welcome you, ma'am. Session is all yours. Thank you.
Thank you so much, Dr. Lavanya. Shall I start the session?
Yes, ma'am.
Yeah. Here my topic is, I'm Dr. Mrs. Manisha P.Gajendra Gadkar. Here the topic I have chosen is homeopathic potentization and quantum mechanics. The main and commonly asked question to any homeopath is, what is quantum mechanics and how it is related to homeopathy? So this is a very bit difficult question because it becomes in quantum physics. It becomes in physics, and this quantum theory is from physics, and how it is related to homeopathy that we'll see today. And I'm going to explain this today with a research paper of Marcin Molesky, quasi-quantum model of potentization. Yes, next slide, please. Next slide, next one. Next one. Today we'll learn related to this quantum theory and potentization. These all are related to potentization. What is quantum? What is quantum behavior? Some basic concepts, conservation of mass and energy, probability function, and now potentization, all of you know. Then important terminologies, Schrodinger equation, time dependent, time independent, Planck's constant, wave function, Coulthon potentials, differential equation, ontogeny, WBE model, conclusion, and connection. How this potentization is related to quantum theory. Next, please. I will explain you one by one now. What is quantum? Quantum refers to a smallest possible discrete unit of any physical properties like atom or any molecule. Right? Next slide. The field of physics that studies and explain the behavior of particle at this scale is called as quantum mechanics. Means in the field of physics, this is called as whenever you study the behavior of the particle in the sense quantum is the smallest particle of anything of the smallest, like atom, molecule, and at this stage it is called as quantum mechanics. Next theory, please. Next slide. What are the properties of quantum? What are the properties of smallest part of the anything? Discrete packets, wave particle duality, superposition, quantum entanglement, and uncertainty principles. Next. Properties of quantum. Now here it is related only wave particle duality, and quantum entanglement. Particles, what is wave particle duality? Particles such as electrons and photons can behave both like a particle and wave. And for example, the electron can act at a solid particle in one experiment, but spreads out like a wave in another. This duality is evident in experiments like the double slit experiments, where particles create an interference pattern typical of waves when not observed, but act like particle when measured. Next one, please. Next slide, please. Now, what is entanglement? So, quantum entanglement. It occurs when two or more particles becomes linked. So, the state of one instantly affects the state of another one, no matter how far apart they are. This means the measuring the property like spin or polarization of one entangled particle will immediately determine the same property for its partner. Albert Einstein famously called it this phenomena as spooky action at a distance. Now, next. What is quantum behavior? Now, what is quantum behavior? It refers to the strange, often paradoxical, that is exactly opposite. It might be exactly opposite way that very tiny particles behave at the atomic and subatomic level. For example, our natrum mur, that common salt, the atomic or subatomic level, the common salt particles will never behave like a salty and whatever the characters they have. They may behave like a opposite. They may behave like opposite. This is called as quantum behavior. Unlike objects we see in daily life, quantum particles don't follow straightforward rules. These they can be multiple places at once, connected to other particles across vast distances, and pass through the barrier that should block them. This behavior forms the basis of modern quantum mechanics, which helps in explain how the smallest part of the universe works and leads to technologies like quantum computing and laser. Like in medicine, the laser, we are doing the laser treatment or laser operations. We are doing the laser computing operation or operation with the help of computers, right? Likewise, quantum behavior. Next one. Next slide, please. Some basic concepts. Right? What are the some basic concepts of next slide? Now we are going to the some basic concepts. Some basic concepts. Conservation of mass and energy. The rule worldwide, or the rule is, mass and energy cannot be created or destroyed. Only it can be transferred from one form to another form. This principle is vital for understanding homeopathic potentization, where the total mass and energy of the system stay consistent even as the active substance, here active substance is drug substance, is reduced repeatedly, but the concentration of solvent, that is vehicle, increases as the drug substance or active substance reduced. This helps to explain how the active substance and solvent maintain balance during potentization. This is very important, conservation of mass and energy. Next step, probability function. Next step, next slide, please. Probability functions. Functions in quantum mechanics predict the likelihood of findings particle in particular states or places. In Molesky's work, these functions are represented by AX and SX, which show the concentration of the active substances, that is AX, and the solvent, that is SX, respectively. The potentization progresses, AX decreases, lowers probability of finding the active substances as the potentization progresses, while the SX increases, higher concentration of solvent becomes in higher potencies. This is probability functions. Next concept. Next slide, please. The homeopathic connection. Now, next slide. I've given the main heading of this different parts. Molesky's experiment. With the following abbreviations, AX is active substance. Here it is referred, in homeopathy, it is referred to drug substance. SX is solvent, referred to vehicle. AT, homeopathic active substances with respect to time. And ST, concentration of solvent, that is vehicle, with respect to time. Next slide, please. Next slide. Yeah. AX plus SX is equal to 1. In decimal, AX is equal to 1 by 10 raised to X is equal to 1 by 10 raised to minus X. Simple, right? Likewise, in centesimal, AX is equal to 1 by 100 raised to X is equal to 100 raised to minus X is equal to 10 raised to minus 2X. Okay. Now, next slide, please. Next slide, please. Potentization of drug in preparation. Now you know the potentization. You know the 3 scales used in potentization: decimal, centesimal, 50 millisimal. I don't explain it because all of you have done it since first BHMS, right? It's first BHMS. If you have done the PG pharmacy, or it is always there. It is always there in your mind. Next slide, please. Yes. Now decimal scale, how it is X and D and etc. etc. The decimal scale is based on the principle that the first potency should contain 1/10th part of the original substance, and each succeeding potency should contain 1/10th part of the potency preceding it, etc. Next slide, please. Likewise, centesimal scale is explained here. Because this is coming later on in the equations, various equations. That's why C, CH, X, D. D is there. D denotes the decimal scale and CH or C denotes the centesimal scale. Next slide, please. Yes, now some basic concepts may. One more thing, AX plus SX is equal to 1. Again, I'm explaining the thing. Now here in down, the table DX. DX means decimal scale potencies. AX means in that decimal scale potency, what is the concentration or what is the part of drug substance, here the active substance. And SX means our vehicle, and here according to Molesky, it is solvent. And C means the centesimal scale potencies. The ratio is given, and total it becomes 1. Okay, total it becomes 1. Right. Now next is some important quantum concepts. Next slides. Next slide, please. Yeah, wave function. Now this is a very important function. Wave function typically present by the Greek letter psi. It is a fundamental concept of quantum mechanics used to describe the quantum state of a particle or system of particle, like particle's position, momentum, and the other physical properties. This is called as wave function. Consider electron in the room, right? Because of this wave function, we might this might indicate that there is 50% chance of finding this electron in the corner, 30% near the window, 20% near the door, etc. With this help of wave function, you can find out, or we can judge that this can be the answer, or this can be the function. Right? Next slide, please. Why is the wave? Next slide, please. Why is the wave function important? The wave function is essential of making predictions in quantum mechanics. So we can predict that this electron can be present in the door, can be present near the window. Likewise, by judging on the wave function, it provides all the information needed to determine the behavior and characteristics of the particle, enabling the calculations for physical properties like energy, position, momentum, so that we can locate the position of electrons with the help of wave function. Next slide. The Schrödinger wave equation. Again, the Schrödinger is Erwin Schrödinger, is one of the physicists, right? He had given the wave equation. Is a fundamental wave equation in quantum mechanics that describes how the quantum state of a physical system changes over time. How it changes over the time, right? Wave function, how it changes over the time. It's used to predict the behavior and the properties of particle, at the atomic, subatomic level, such as electrons in the atom, right? In the atom also we are going to the electrons. So in that small quantity we are going and we are finding out the wave equation. The equation was formulated by physicist Erwin Schrödinger in 1925 and is central to understanding how particles behave in the quantum world. Means they might not behave like their original particle or original substance, because they are very small and they can behave like other things also, or it can be a straightforward. Next one. Next one, please. The important concepts. Time-dependent Schrödinger equation. Now it is depend on the time dependent and not time dependent. Time independent. Describe how the wave function psi of the particle evolves over time. Right? Explanation. What is the explanation of this? This equation tells us how the wave function, which describes the probability of finding the particle in a certain place at a certain time, changes at the time progresses. For example, you have a bicycle and you have a stand at one place. As the time passes, if you're moving, as the photon or electron moves, if you're moving, you will be at another place as the time changes or progresses, right? Likewise, it changes, it is time dependent. If Schrödinger equation, the equation tells us how the wave function which describes the probability of finding a particle in the certain place at a certain time and changes as time progresses. Next slide, please. Applies to this time independent. Now, what is time independent? Now this applies to the system where the energy does not change with the time. That is stationary state. Now we can say it in homeopathy, we can say it as a potential energy. If I'm not moving from my one place, then how can I change the place? How can I change the place? It is time independent. I'm not moving. It is a stationary phase. While in time dependent, it is moving. So it can be in a kinetic phase of the energy. Next slide, please. Now, important concept, one more important, Planck's constant is a fundamental physical constant that plays a crucial role in quantum mechanics, linking the energy of photon to the frequency of its associated electromagnetic waves. Planck constant acts as a bridge between the particle-like wave and particle-like and wave-like behavior of the matter and energy. Here, in this experiment, the photon is moving. The photon or electron, it never stay at one place. It is always moving and forming a wave. It shows a wave property, so forming a band like around them, and that energy in it, having that energy in it, like so this is a band like as well as energy, and this Planck's constant is the bridge between these bands and energy itself in the particle. It is moving as well as the particle energy is there, as well as as it moves, it forms a band around it. It encircles the band. Like next slide, please. Now the concept, important concept of Hulten potential. This is very easy as compared to the other Schrodinger and Planck's constant. Hulten potential is a type of potential energy functions used in quantum mechanics to describe the interaction between particles, particularly in scenarios involving short-range forces. So it is named after the Swedish physicist Lars Hulten. Next slide, please. Now, what is Hulten's potential? In quantum mechanics, solving the Schrodinger equation with the Hulten potential allows a researcher to find wave function and energy level for particles under its influence. Imagine two particles in a box. When they are near each other, they feel strong attraction, like two magnets closer together. But as they move apart, the attraction weakens really fast, and soon they don't feel each other at all. In the simple word, Hulten potential, a force between particles that's strong when they are close, but quickly gets weakened as they are moved apart. So this is Hulten, right? Next slide, please. Slide, please. Yeah, back to the maths and potentization. Next slide. Next slide. Now we are going back to the maths with potentization. AX plus SX, same decimal and centesimal scale. Next slide. Potency with time dependency. Now the time dependent version of the earlier equation is given as, it was AX, now here it is AT, right? It was AX, now it is AT, that is active substance and in time dependence, is equal to 10 minus X in T. Okay, now this is equal to exponential minus AT. A means here Planck's constant. Planck's constant. A stands for Planck's constant. This is the equation given by Molesky and calculus. This is for calculation of calculus base equation for exponential. This is not exponential. This is exponential. EXP. This equation is given by Molesky. Then different. Next is this concept in maths. Different equations are mathematical equations that describes the relationship between function and derivatives. Again, this is like mathematics. They play a crucial role in modeling how things changes over time or space in various scientific fields such as physics, engineering, biology, and economics. The derivative is fundamental concept of calculus that measures how the function changes at its input changes. Next slide, please. Now, this is for time Molesky experiment for time dependency. Now this is for solvent like our vehicle. St is equal to 1 minus 10 raised to minus xt. 1 minus exponential minus at, second degree derivative d2 st upon d2 square dt square plus a2 a square e minus at divided by 1 minus e minus at st is equal to 0. This resembles a quantum equation used to describe particle interaction at the microscopic level. Next. Yeah, the same dimension, the same in dimensionless, time independent coordinate. This is tau is d square s tau plus divided by d tau square plus exponential minus tau 1 divided by 1 minus exponential minus tau. S tau is equal to 0, where tau is equal to at. Right, at means here A is Planck's constant and T means time. Right, next please. Now final piece of puzzle. The next one more theory or concept is there. Next one more concept is there. Ontogeny. What is ontogeny? Is the process of growth and development of the individual organism from the earliest stage of life to maturity. This encompasses all the biological, physiological changes an organism undergoes from the fertilization of egg to its fully developed form. Right? What is ontogeny? Now next, like ontogeny is nothing but development. Now this West Brown, yeah, it is nothing but development, biological, physiological, etc. changes in organism. Now the next slide, this West Brown Equist, they have prepared a model, is a theoretical framework in biology that explains how metabolic rates and other biological process scales with body size in organisms. Means how it grows. It was developed by Jeffrey West, James Brown, and Brian Inquist to provide insights into the relationship between an organism's size, metabolism, and energy use across different species. They have given the concept, they have given the model, and this model is used by Molesky. Next slide, please. This time-dependent WBE West Brown Equist function, right? This M is first, that is mass. T means time dependent mass, then is equal to M. That big M is the end product, that is total mass. 1 minus C0. This all is given by Molesky after its after considering all the WBE model. M0 is the initial mass of the system. MT is the mass of the system with respect to time, and M denotes the maximum body size reached. Means maximum development right from the conception, from egg. Next one. Now the actual correlation. The next slide. Ontogenic growth and potentization. Now, what is this ontogenic growth? Here, the Molesky adapts WBE model to describe how the concentration of the solvent increases during potentization, implying that the medicine grows in potency. Right? As the potentization increases, how the solvent increases, concentration increases during potentization, implying that the medicine grows in potency. Now, next one. Now, what happens? How the paper links potentization to quantum physics. Now, what happens in quantum physics? Information transfers, just like quantum system, can carry information in non-traditional way. Molesky argues that even after extreme dilution, the succussion leaves an imprint of the original substance in the vehicle. Here the original substance is drug substance. And the quantum behavior in quantum physics, particles behave like waves and don't have exact position. Molesky suggests that during the potentization, the vehicle might behave in a similar wave-like quantum way, forming a pattern that remember the substance, the original substance, right? The next, no molecule needed. No molecules needed. Just like quantum physics, where particle can be in multiple states or influences each other at a distance, entanglement, Molesky proposes that even when there are no molecules left, the solution might still carry quantum information from the original substance. Here we can relate it to potentization, because in potentization, in higher potencies, we don't see the exact original substance or active substance. Here it is called as active substance, but we can see the effect, or we can carry the quantum information of the original substance. Now, growth analogy. Now, how it grows, like WB right? Molesky compares the increase in potency during potentization to biological growth. He uses a mathematical growth model to show that the process of potentization follows a similar pattern to how living thing grows. This growth-like process can be seen in quantum-like behavior. Growth-like process can be seen as quantum-like behavior. Thus, we can correlate this quantum mechanism to the potentization. Next slide. And this is the last slide now. At the end of paper, what Molesky suggests, that potentization is not just a process of dilution, it also involves activating the solvent through mechanical action. This action might create structured pattern in the solvent that carry the information from the original substance, even when no molecules of that substance are left. This is what potentization is. Now, we can a little bit, I have tried to explain you how the quantum mechanism or quantum theory is related to potentization. Here finishes the my topic. Here finishes my topic, that homeopathic potentization and quantum mechanics. Hello.
Thank you, ma'am. Thank you so much for enlightening us with the wonderful session. Respected participants, if anyone have any questions, they are welcome actually. Thank you so much, ma'am. Thank you so much for the wonderful session.
Thank you so much, Dr. Lavanya. Thank you very much. Thank you. Shall we end this session? Hello.
Actually, the participants might have any question. Just
Okay, okay, they can ask the question.
yes.
They can ask the question.
Milan Sen Gupta, sir, you have any questions, sir?
Yes, any questions? Yes.
Yes, ma'am. Ma'am, I think they are very clear with the topic. It seems that they don't have any questions.
Okay. I have touched the very different topic. Actually, I have touched very different topic today.
Yes, ma'am. Yes, ma'am.
Hmm.
It was quite informative, ma'am.
Hmm. Yes.
Respected participants, today here are the details regarding the International Oish Conference, which is going to be held on 12th January 2025. It will be conducted online, come offline in West Bengal, Kolkata, Salt Lake. So the registrations are open, and the registrations end time is regarding the will be ending on November 30. So everything, every detail and the registration process details have been embedded in the Homeo book website of the Aisha page. So kindly check it out for the further participations of the competitions also, and in the OIS Fest. So there are many competitions in which OIS been conducted by the in the OIS Fest. So kindly check it out. Thank you all. Thank you so much.
Thank you very much. Thank you.
If there are any queries, you can revert us back to the given mail IDs, and you can contact the contact number given provided in the end page. So there are many nominations also for the awards. So kindly check it out for every detail in the Aisha page in the Homeo 360 degrees. Yeah.
Thank you. Thank you so much.
Thank you. Thank you. Thank you.
Shall I leave, Dr. Lavanya?
Ma'am, actually, video regarding the conference is playing, ma'am. Just give us a
Yeah.
couple of minutes, ma'am.
Okay. Okay. Yeah. Yeah. Sure.
Okay, ma'am. Okay.
Sure. Yeah.
Thank you all. Thank you so much, participants. Thank you so much, ma'am. Tomorrow we'll get back with the one another wonderful session. So stay tuned for the further updates of the